What has emerged from the latest study on Earth's freshwater systems is far more than a sobering scientific report. It is a warning flare, one that underscores how close we are to pushing a vital part of our planet's life support system into irreversible decline. According to researchers at Utrecht University, the freshwater oxygen cycle, the delicate process through which rivers, lakes, and reservoirs produce and consume oxygen, has been dramatically disrupted over the last century. We are not just straining these systems, we are suffocating them, and the consequences may soon prove catastrophic for both ecosystems and humanity. The science is clear and deeply unsettling. For the first time, researchers have created a comprehensive global model of oxygen flow in freshwater bodies, and the results indicate that these waters are now consuming more oxygen than they can produce. This imbalance has enormous implications. Oxygen is as critical for aquatic life as it is for life on land. It fuels biological processes, supports fish and plant life, and maintains water quality. When oxygen levels drop too low, a condition known as hypoxia, life within those waters begins to die off. And this isn't happening in isolated, remote areas. It is unfolding across continents, affecting lakes and rivers that communities depend on for drinking water, agriculture, sanitation, and economic survival. This shift didn't happen by chance. It's the predictable outcome of a century of aggressive human interference. Nutrient pollution, primarily from the overuse of fertilizers in agriculture, is feeding explosive algae blooms. These algae, once dead, decompose in a process that rapidly drains oxygen from the water, effectively creating aquatic dead zones. Add to this the construction of dams and reservoirs, which slow the natural movement of water, trap organic material, and prolong its decay. The result is a doubling down on oxygen depletion. These stagnant or slow-moving waters become oxygen sinks rather than sources, making freshwater systems net consumers of atmospheric oxygen for the first time in modern history. The damage doesn't stop with algae or oxygen. As oxygen is used up, the water chemistry shifts, releasing toxic substances like methane and hydrogen sulfide, which can poison aquatic life and further degrade water quality. Fish kills, collapsing food chains, and increased greenhouse gas emissions are just some of the documented side effects. What was once a balanced, self-sustaining ecosystem is now lurching toward dysfunction. And while warming temperatures do contribute to this crisis, by making oxygen less soluble and accelerating decay, scientists now say this accounts for only a small fraction of the problem. Human land and water management are the real culprits. What makes this crisis even more dangerous is its invisibility. Unlike deforestation or air pollution, freshwater oxygen depletion happens quietly and often out of sight. A lake may look calm on the surface while silently dying underneath. And without active monitoring or intervention, we often don't know a system is collapsing until it's already too late. Once an aquatic ecosystem has undergone hypoxic collapse, recovery can take decades, if it's even possible at all. The implications reach far beyond local biodiversity or recreational losses. These freshwater bodies play critical roles in carbon and nitrogen cycling, in regulating climate, and in sustaining agricultural productivity. As they falter, so too do the planetary systems they support. The removal of nearly 1 billion tons of oxygen from the atmosphere by freshwater systems every year, half the amount the entire ocean emits, is not a statistic to be brushed aside. It signals a global imbalance that could alter climate dynamics, disrupt natural carbon sinks, and place new pressures on marine environments already at risk. The Anthropocene, our current human-dominated geological epoch, is leaving a clear, destructive fingerprint on these systems. Our attempt to mold nature to meet short-term goals of food production, energy generation, and urban expansion has severely underestimated the cost to the very ecosystems that support life. And now, the margin for error is vanishing. This is not a problem that can be solved with a single technology or policy. It requires a complete rethinking of how we manage land, water, and waste. Agricultural practices must be overhauled to reduce nutrient runoff. Dams must be assessed for environmental cost and, where possible, removed or modified. Wetlands, which naturally filter water and replenish oxygen, must be restored on a massive scale. Cities must invest in advanced wastewater treatment and monitoring systems. Without decisive action, we risk allowing entire freshwater networks to degrade into lifeless, toxic zones. The language scientists are using, a global emergency, is not hyperbole. We are altering the oxygen balance of our planet, threatening the resilience of ecosystems that have existed for millennia. If this trajectory continues, the consequences will be felt not only by aquatic life, but by all species, including ourselves. We are confronting a clear and present danger that demands immediate and systemic response. In the race to protect our planet's life support systems, time is running out, and the water is running low on breath.